Hello students, welcome back to Engineers Academy. Do hit the subscribe button if you are here for the first time. Now we are going to solve this problem from chapter 2 Engineering Statics by Meriem and Kraige 8th edition, and the problem says that the force F has a magnitude of 7 kilonewton and acts at the location indicated. Express force F as a vector in terms of the unit vectors I and j. Next, determine the x and y scalar components of this force F. So we are given this force F, which is acting at the coordinates of -4 and -5, and it is making 25-degree angle with the line which is parallel to the y-axis. So as we know that it will have two rectangular components, it will have one component in the positive y direction. So this will be f of y, and here we will have this will be the f of x, and the sum of f of x and f of y, they must give us that force F by head to tail rule. So we can say that we are given that force F, which has a magnitude of 7 kilonewton. So let me write it as 7 kilonewton, and we will have f of y. This will be our f of y, and this force F is making 25-degree angle with the line which is parallel to the y-axis. And similarly, we will have f of x. This will be f of x. So f of x is, if this is our positive x, this is our negative x, so f of x is in the negative x direction. Similarly, we can complete the parallelogram. We can draw that f of x here as well, and we can draw that f of y here as well. So if we add f of x and f of y by head to tail rule, the resultant must be that 7 kilonewton force. Now, as I have told you guys in the previous videos, that if the angle is made with a line which is parallel to the y-axis, then the f of y component is the cos component. Or we can say that if the angle is made with f of y, then f of y will be the cos component. So we can directly say that f of y is 7 kilonewton cos of 25-degree, because f of y is adjacent to the angle, and f of x is opposite to the angle, then f of x is the sine component. So we can say that f of x is equal to 7 kilonewton sine of 25 degrees, is f of x is opposite to the angle. And similarly, we can say that f of y is equal to 7 cos of 25, because f of y is adjacent to the angle, and the angle is made with f of y. Now f of x is acting in the negative x, so we will write minus sign with f of x. So this will be minus 7 sine of 25 degrees, and f of y is plus 7 cos of 25 degrees. So we can say that 7 sine of 25 is 2.96 approximately. So we can say minus 2.96, and this will be in kilonewton because the force magnitude is in kilonewton. And similarly, 7 cos of 25 is, we can say, plus 6.34 kilonewton. And since we were asked that express this force F in terms of the unit vectors I and j, so we can always say that F vector is equal to Fx vector plus f of y vector. So we know that this is the f of x has a magnitude of 2.96 kilonewton, and it is acting in the negative x direction. So now we can say that this f of x, this is the scalar component of that force F, and this is the scalar component of that force F, which is a magnitude of 7 kilonewton. Now we can say that f of xi, or we can say f of x vector, will be equal to f of x magnitude, or we can say that the scalar component times the unit vector. So f of x is acting in the I direction, and we know f of x. So this is the scalar component. So we can say that f of x will be minus 2.96 I, and similarly f of y vector will be equal to f of y in the j direction. So we can say f of y, that scalar component, which has which is 6.34 kilonewton, and the posit in the j direction, right? And the magnitudes are in kilonewton, and this is in kilonewton as well. So now we can simply write it here. So f vector is equal to minus 2.96i plus 6.34j. And if you guys are confused that why the f of y is the cost component, so again I will repeat the same procedure. If we consider this right angle triangle, and if we apply cos of 25 to this right angle triangle, so we can say that cos of 25 degrees, so cos of 25 will be equal to the adjacent side divided by the hypotenuse. So the hypotenuse is always opposite to the 90-degree angle. So we can say that cos of 25 will be f of y divided by the hypotenuse, which is that force F, which is a magnitude of 7 kilonewton. So from this we can say that f of y, if we multiply both sides of the equation with 7 kilonewton, then we will have f of y equals to 7 cos of 25 degrees. And similarly, if we apply sine of 25 degrees to that right angle triangle, to this right angle triangle, so sine will be the perpendicular, or we can say that the opposite divided by the hypotenuse. So we can say that this will be f of x divided by 7, and again if we multiply both sides of equation with 7 kilonewton, then we will have f of x equals to 7 sine of 25 degrees. So again, the component which is adjacent to the angle, or the the component with which the angle is made, is always the cos component, and the other component will be the sine component. So this is the solution of this particular problem. I hope this will help. Do subscribe Engineers Academy for the solution of such more problems from Engineering Statics by Meriem and Kraige, 8th edition.